With the release of Femap version 2021.1, Siemens Digital Industry Software has added support for MSC Nastran Solution 400. In this video, we will review the steps to create a Femap analysis set to simulate roll forming using MSC's implicit nonlinear analysis. Femap supports the following Solution 400 hyperelastic materials under the other material types: Mooney-Rivlin, Hyperfoam, Ogden, and Aruda-Boyce. Femap version 2021.1 has also added support for the Solution 400 cohesive material used to model composite ply delamination using cohesive elements. Property extensions are used for the assignment of geometric and material nonlinearity to properties. For MSC Solution 400, these are used in lieu of element formulations and are referred to by MSC as secondary or auxiliary property options. Assign property extensions by clicking the Define Property Extension icon in the Define Property dialog box. The Solution 400 elements that can be assigned property extensions are rod, bar, beam, plate, plane strain, laminate plate, axisymmetric, solid cohesive, and solid laminate. In this Femap model simulating a metal roll forming operation, there are connectors between the 3 die rollers and the material blank. The material blank is a nonlinear plastic material, and the dies are driven using 2 rigid elements to tie the rotation of the drive roller to the other 2 rollers. We are now ready to define a Femap analysis set for a MSC Solution 400 simulation. We'll begin by creating a new analysis set. In this case, we'll set the analysis program to MSC Nastran and the analysis type to implicit nonlinear. I could define the location of output and also assign a base name for the model. In this case, I need to use MSC Nastran version 2004 or later. Click my Next button. This opens the bulk data options, and in this case, I need to enable large displacement. I'll close this and expand my analysis set. The first thing I'd like to take a look at is nonlinear behavior. So I select that item, and I want to turn on nonlinear behavior options. And I want to enable nonlinear behavior options. In this case, I need to change my large strain formulation to hyperelasticity and set my assumed strain. I can enable automatic contact parameters, turning that on, and then I can also turn on contact solver options. And this can enable additional contact parameters. I don't need to do that in this case, so I'll close that out. And again, I can also add contact parameters through this object in the analysis tree. At this point, I'm ready to define my loads and constraints in any subcases. So I'll click on Master Requests and Conditions, edit that, select my analysis type. I have the option to do statics, normal modes, or transient. Click the Next button. And because I'm going to use a subcase, I'm going to skip this step. I'm now ready to define a subcase. So I'll create a new subcase, again, use statics, and we'll call this the die engagement. And because I'm going to use analysis steps, I'm going to skip the NL step again in this case. Click OK. And now I go to where my analysis steps are defined, click New, create a new analysis step. I can create one manually here, or I can use global steps. So I'm going to select global steps, create a new global step and define a new global step through the Global Analysis Step dialog box. Again, you specify the analysis type. You give it a subtitle. So again, I do dye engagement. Click the Next button. And now I can set up my step parameters. In this case, I want to set my nonlinear to severely nonlinear. I can set up my maximum minimum iterations as well as my maximum bisections. In this case, I also could set my increment type. I could do arc length, and when I click on that, I can set the arc length load stepping parameters. But since this is statics, I can use the adaptive as well. I get to hit the increment parameters, set my control for my adaptive load stepping. In addition, I can click the criteria button and set up user criteria parameters using strain, stress, temperature, displacement, or rotation. In this case, though, I'm going to use a fixed increment type, and then I can set up my increment parameters. In this case, I'll use the default of 50. And if I want to, I can set up any mechanical analysis parameters. I have my control parameters defined, and now I need to define my boundary conditions. So I'll select my constraints and loads, any of these other options, any of these other sets. And in addition, I'm going to say I'm going to use all three connectors. If I want to use a subset of connectors, I can define these as groups and select that through a connection group. Also set my B contact options. And then set my output requests. So I'll use displacement, force, stress, and strain. I've got that completed. And now that is assigned to my analysis set. So now I'm ready to run my simulation.